Alright, hello, welcome to Turing Complete. I did try to stream this earlier, but my dad called and it was an important conversation, so please ignore that. I know I had it on the waiting screen for like an hour. I'm so sorry. But also, there's only 2 people viewing. Anyway, before my dad called, I did manage to get input-output finished on this game. And so basically what that was I would turn on the input, and the output would turn on. And I would turn off the output, and the output would turn off. And now I'm on the 2nd level. Alright, so in this level the challenge is to figure out how the NAND component works. Or not AND. Be sure to figure it out before you complete this level, or you will get stuck next level. Righty. So essentially what this is, I think what I have to do... Okay, I see. Yeah, so what a NAND does basically is when, how am I oh, I see. So essentially you want not AND. So if both are on, output turns off. If only one is on, the output is on. If this one is on, same thing. And if, but if both are off, it also turns on. So if both are off, it's on, off. Correct! You have unlocked the NAND gate. Yes, so, yeah. With this component, you can build everything else in your computer. Yeah, you can do a lot with a NAND gate. Unlocks NAND gate. Yes. Onwards. Now that you have unlocked the NAND gate, it is time for you to build a circuit. Cool. Last level you made the table that described the circuit. In this level, you build the circuit that matches the table. Alright? I have to build a NOT gate. Using NAND gates, build the NOT gate. I have actually done this in class, I think. Yeah. So basically I just want the opposite of what I'm putting in. So I want to focus on the double inputs. Okay. So here's in. Oh, okay. Yeah, so it's on unless both inputs are on. But I want not. So this is going to require at least one NAND gate. I think it's going to be 3 if I remember correctly. So I have 1 input. Okay, I have 1 input. Wait, okay, I gotta think about this. I think I may actually only need 1. So basically this is going to both. And now, if input is on, it's off. And an input is off, it's on. Okay, I did it. Yeah, because it's not and. Yeah, so it's just okay. Input, yep. I build a circuit, click next, tick in the upper left corner to test each combination of inputs. You win the level once both combinations have been tested correct. Run, tick, okay. Yeah, so this, okay, yeah, so there's a NOT gate. That's known as an inverter, usually. And then also level map mode. Okay. Interesting. Ooh, that's gonna get complex. Ooh, I like that though. I think this is gonna be fun. Alright, so these three are complete, and I have these three gates now. Yeah. Alright, so let's do this one. Most creatures on Earth are aggressive and do not know how to concentrate. To succeed in this next test, you will have to learn how to place components in circuitry while not destroying test equipment. Okay. Does that just mean I can't turn it on until... Okay. Alright. And I can't turn on output. I can't change output. Alright, so... IRL221, dude, what's the deal with you? Hello and welcome to chat. Welcome to this game. What do you mean by what's the... Well, I had to ban somebody. Hate chat is not tolerated here. Just, yeah. So IRL221 has been banned because, you can't say shit like that here. You can swear, you can send rickrolls to the chat, you can't be mean to other people. It's real simple. One of the rules is be kind to each other. Anyway, so for this one I'm gonna want a NAND, I think. So we'll see. So hold on. Okay, so both are off and it's on. Now if input 1 is on, I need it to be off. So I'm thinking I need to be putting that in. So when input 1 is on, maybe I need them both to be inverted? So when they're both off, no. This doesn't make any sense though. Wait, okay. Wait, hold on. Okay. Yeah, so that's what I wanted. And then it's on and it's off. And that's off. That's off. Okay, that's what I wanted. I don't think I need those two here, though. Whoops. Alright, let's try it. There we go. And that's the NOR gate. So it's on when neither input is on. Onwards! You should be happy you get to participate in our glorious tests. You get a chance to communicate with the very advanced people from the galactic civilization. Okay. So, when it's all... Okay, so this is an OR gate. But I only have NAND and NOT. So I need a NOT AND. So I think I just need to invert both of these. Let's try it. Yep. Manual entry. And, yep, the OR gate. Onwards. I don't want to discourage you, but I think the elephant will win the competition. No offense, but your brain is tiny in comparison. Well, rude. You've got a 6 head. Shut up. I know I just said be kind in chat. This is a video game character, so, fuck that guy. Create the circuit that matches the table. Double-click a component to also select its pins. Okay. Okay, so it looks like... Yeah, so I'm just inverting a NAND. Oops. Meant to stretch that further, but oh well. Yeah. An AND. Onwards. Cool. Yeah, we're still in basic logic, but we're getting there. Create a circuit that is always green. Okay. So what I'll do is I'll do an OR gate. And I'll also... Oops, shit. So there'll be that. And then I'll also have an inverter. So that when it's on, it'll trigger this, and when it's off, it'll trigger this, which will trigger that. Yep. You've unlocked the ON component, since its signal is constant and doesn't cost any NAND gates. Cool. Onwards. There's a question mark. Unlock something unknown. As you know, these tests culminate in building a functioning computer. Yes, I did know that. Species that are capable of finishing are considered sentient by law. I believe that's known as the Turing test. I may be wrong, but I don't think I am. This is the main reason we don't eat you afterwards. Oh, well, thank you. Output green on second tick only. Okay. So, I think what I want is an AND gate. But input 2 is inverted. So we'll try this. Yeah, so that's off. That's on. That's off. And that's off. Yes, that is what I wanted. Yep. Unlocks a tip. You can select a component with its pins by double-clicking it. I already knew that. Alright, last level you built. What? Last level you built a circuit that was green when we were at the second tick. This level, build a circuit that is green when we are at the second or third tick. Okay. This is also known as an XOR gate. This level is difficult, so don't be discouraged if you don't get the answer right away. Okay, so essentially... Okay, so NAND... So what I can do is I can invert a NAND. No, what I'll do is I'll do an OR. No, but a NOR. So if I invert a NOR, that's just an OR. Hang on, what is the AND? And then, okay, let's try an AND and a NOR. So, oh, and then I can OR those together. That should work. Alright, nope. Wait. Okay, so I just want to invert that. There we go. Yep. And that's the XOR gate. Yeah. Onwards. Oh, okay. It gets real complex from here on out. Alright. Create an OR gate with 3 inputs. That's easy. That's just 2 OR gates. Yep. That unlocks 3 input OR. Okay. Create an AND gate with 3 inputs. Again, that's super easy. It's the same exact thing. Yep. Onwards. Create the inverse XOR gate known as XNOR. That's easy. You take the XOR, invert it. There we go. Unlocks XNOR. Onwards. Alright, yeah, we'll just work our way left to right. This level is my favorite pastime, converting decimal into binary under time pressure. Time pressure?! Toggle the bits in the level panel so they add up to the decimal number in the question. You must reach level 3 to pass. Click here to turn on timerless accessibility mode. Hold on. Okay, toggle the bits so they add up to the decimal number in question. Ready to race? What's 1 in binary? It's 2 in binary. 3. 13. Yeah. 6 in binary. 11 in binary. Oh shit. Fuck. There we go. 12. 1 in binary. 14. It's 22. 16, 22. 21, 16, 20, 21. 2. 4. 19. 31. 3. 2. 37. 62. 32. 7. 38. 42. 38. 14. 18. 47. 71. Whoop. 121. 11. 96. 109. 5. 109. Whoops. I guess I just had to keep going until I ran out of time. Okay. Because we are so technologically advanced, we have machines fold our socks. Unfortunately, the circuit that detects sock pairs broke on the machine. Okay, this level has 4 inputs. Input green when 2 or more of them are green. Don't overthink it. When 2 or more are green. It's 5 input. Oh no, okay. So, I'm kind of thinking we do... Oh no, I just want... Kind of thinking 2 ors. No, we need to do 4 ors, I think. Because I want to do that. No, they said don't overthink it. So... So this is gonna be an OR situation. But it needs to be at least 2. So I guess what I can do is have 16 AND gates. Or something close to that. So we'll just... I'm not even counting. We'll do this. So then I want this one. That's already gonna be ended. Alright, so that should be all I need, actually. Oops. And then I can just OR them all together. And that should work. Maybe. Let's try it. Hey, it worked! Alright, using a maximum of 3 components. Output green only when an odd number of inputs are green. This level has a hint you can use to get... Oh. If you figure out 2 inputs, have an odd number of green with just 1 component. Well, yes. Okay. So that is... that would be the X or... Yes. So we'll do 2 of those. And that'll tell us if we have an odd number. And so I guess that's gonna be... Alright, so there's an odd number, there's an even number, there's an odd number, there's an even number, but what if I have... Yeah, there's an even number though. So I think I want another XOR. So let's try that. Alright, that worked. Wire color. Ooh. Wire comments. Okay. In our education system, we traditionally teach by tricking students into doing the wrong thing and then teasing them. That is accurate. I'm not sure it benefits the students, but teachers love it. Create a circular dependency. This is a circuit where the input of a component relies on its own input. In a circular dependency situation, it is not possible to determine the output of a component because you would first need to determine the input, which relies on the output, so on, hence the circular. This state is normally not allowed in other levels, but in this level the goal is to create it so you'll understand what it is before going forward. Okay. Make a circuit where the input of a component depends on its own output. Oh, I accidentally clicked check. No. Hang on, do I not have an input? I guess not. So I'll do an XOR. and an inverter. Just because I can. Yep. Create circular dependency involving at least 2 components. I did that. Yes, I did. Level complete. Oh yeah, and you don't need to have 2 inputs to a component. You can do only 1. It's just the other input will count as off. Circular dependency. Onwards. So I'm gonna unban that guy. He's gonna be emote only. Oh, I can't do that. What can I do? You know what, he'll just get a second chance. He probably won't come back. But maybe. We'll see. And if he's still mean, he's gonna get banned for good. The output component of this level is a binary counter, where the first 3 pins correspond to 1, 2, and 4. Yes, that is indeed a binary counter. Use the binary counter to count the number of signals. The solution is not very neat. Yeah. The circuitry for ones is a bit... The ones bit is the same as what you did in the level odd number of signals. The circuitry for the twos bit is what you did in Double Trouble, except when all 4 are on. Okay, so I'm just counting how many are on. And my guess is that it's gonna count how many signals it's getting. Oh, I see. Okay. So it's gonna be 1, 2, 4. How many colors can I do? I can do lots of colors. Cool. I'm gonna start with green for the ones. So actually for 0, I don't think I need to do anything for 0. This is complicated. So I guess what I'm going to be doing is checking for an odd number first. So I'll do that up here. Oh, that's a pretty color. So I'll do that. Up here like that. So this is going to be checking for 1 and 3. And so if only 1 is on, hold on, so we want an odd number Okay. Alright, so if either of these are... So this will be on if there's an odd number in the top. This will be odd. This will be on if there's an odd number in the bottom. This will be on if only one of them is on. So I believe that's for a 1 only. So I'm going to check that. So that's 1. Okay. Okay. So I've got the 1 taken care of. So I'll switch to another color now. Let's do orange. So for 2, there's only 2. Shoot. I think for that... do 3, 4, 5, 6. Trying something, it's not gonna be good. It's gonna look terrible, I think. Alright. So now, if any 2 of these light up, one of these will be lit up. So let's say I do input 2 and 4. That one will be lit up. So now what I want, I guess, is I want to check for more than one of these to be lit up. Because if only one lights up, I guess that's gonna be an XOR. So I only want one to light up. So we'll do that. So now if I've got 2 and 3, one of them is lit up. Uh-oh. Okay. So what I can do is OR these together. and that'll go to the 2 spot. So if only 2 of these are lit up, it'll show 2. Okay. But if all 4 are lit up, it's not going to show it here because I don't have anything hooked up there. But if I have 2 ands, and then I'm going to AND those together. That'll do that. So if all of these are... yes. Okay, good. Wait a minute. It looks like I accidentally got 3 as well. Let's try it. Hey! That did it! Cool. Alright, so I unlocked manual entry, binary, and there's no shame in using pen and paper. Oh, well, I didn't. We measure the universe with numbers, so your machine must learn to count. Treat the inputs as 0 or 1 depending on if they are off or on. Add them together in binary such that the result is either 0 or 1. As with normal addition, if the result cannot be described with 1 digit, set the carry to 1. Okay. Okay, so I'll use an XOR. Inverted. No, an XOR for sum, and then for carry, I want an AND. Yep, and that did it. Unlocks Brain Companion. It'll congratulate you after completing a level. Plus 38% motivation. You can't decide that for me. Alrighty. I guess I just get to skip over that now? Okay. Ooh, there's 8 inputs now, and 8 outputs. The input and output of this level are using bytes instead of bits. One of the 2 new components you were given takes a byte and splits it into bits, and the other does the opposite. Using those components, figure out how to double the input number up to 127. What? Wait, okay. So if I've got 16 here, I want to add 16. So... okay, so if I do that... okay, so that's 1, 2, 4, 8, 16. Okay. So I think what I actually want to do is just something like that. No. Alright, so I've got a byte splitter. And I'm gonna put it into a byte maker. So if I have 1, I want it to become 2. And if I have 2, I want it to become 4. And if I have 4, I want it to become 8. And if I have 8, I want 16. And for 16, I want 32. For 32, I want 64. For 64, I want 128. Now here's the problem. If I have 128, I want 2 of those. So I think what I'll actually do is I'll try this. And so if I have 128, maybe? Nope. Why is that going back to 64? Okay, so yes, I do want that to go there. If I have 128 though, do I want it to... No. Hang on. So I guess it doesn't matter if I have 128. They're not making me double 128, I guess. Well, onwards. In the previous level, we added together 2 inputs. This time we add 3. Okay. Once again, add the inputs together in binary such that the result is either 0 or 1. As with the normal addition, if the result cannot be described with 1 digit, set the carry to 1. Cool. Alrighty. So... okay. So it looks like any with an odd number... No. No. Why is it... I'm gonna do blue, because I like blue. Okay, well, let's just go ahead and start with the triple and. If all three are AND, then the output goes to both. Yes. None of the others are going to do that. Now I'm going to switch to green. Okay. So... an XOR will take an odd number. So I guess I'm only looking for ones. So that should be easy enough. So we'll do that and that. And that should go to the sum. I guess I don't get a color code. Fine. So... that's not what I want. I think what it... well, simple fix, I guess. There we go. Yes, so that's feeding into the sum. And if all three are on, that feeds into both. Yeah, alright, that looks fine. Now for 2s, I want it to carry. So if any 2 of these are on, I want it to carry. Only carry. So I actually need to delete that real quick. Put another OR gate in there, since it's being weird. Yeah, I'll put it in like that. Do orange. So for any 2 of these that are on, so I think what I want to do, I don't want to use the 3 input AND. I think I want to use 3 separate ANDs. And then OR it. So if any of those are on, we'll OR it, and that's going to go to the carry. Yep. Full adder. Okay. Cool, we got a full adder. Alright. You just learned how we don't allow circular dependencies. Now you must learn the exception. In this level, you must build an SR latch, which stores memory. This is the only level in the game that allows circular dependencies. So we're storing memory. Alright, consider this circuit just 2 NOR gates in a row. Yeah. Adding this magenta wire doesn't immediately change anything until we turn the input on. Okay. Yeah, that didn't change anything. Okay. So if I have a wire here, would that put it there? It would. Okay. Tangled gates. So if input 1 is on, we want output B to be on. If neither are on, we want neither. Oh no, we want output B. If only 2 is on, we want A. And then if neither are on. Okay, so yeah, it's a latch. Yeah. That's odd. It's a weird little thing. But yeah, all of those are right. SR latch, 1-bit memory. Onwards. You may think it's unethical to eat all of the Earthlings that don't win the competition, but actually it's okay because you lived good lives in the wild and we don't let the meat go to waste. Oh, thanks. Or together on each bit of the byte inputs. Okay. No, I want that. No? Oh. Interesting. I don't know what it... So if everything is off, it'll be on. Oh, there's current output. Hold on. All it said was to OR it together. Hang on, okay. Or together on each bit of the byte inputs. Okay. So that's 1, 2, that's gonna be 8. So I want 2, 3, 4, 5, 6, 7, 8. Reposition that just so it looks nice. And I'll do gray for in and the ones. And then white for 2s. No, 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 I think I want to put these closer, like that, so I can do a byte maker. Yes. Yeah. Alright, and that is going to go down to the 1 and out. And then we'll have white go to the 2s, orange for 4s, pink for 8, purple for 16. Darker purple for 32. Blue for 64. I think it just looks pretty. And green for 128. There we go. So now next tick, 218 and 81. $125. Okay, so I just built an adder. No, I didn't. So that's 222 plus 3. Oh, I think it's taking the highest digit in each place. I think. No? Byte or. Bitwise ors together 2 bytes. Not sure why you would want that. Our previous model of the brain size being the main predicator of intelligence was naive. Tool making and usage is key in the early evolutionary stages of developing intelligence. Therefore, the number of arms on a creature is clearly the main predicator of intelligence. Did you know there are sea creatures from your planet with 4 times as many arms as you, and they are doing better in tests? Probably like the octopus. Not each bit of the byte input. Okay. I don't know why you want that. That's pretty simple. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to use the same color for each of these. We'll do 4, 8, 16, 32, 64, 128. That's certainly what it wants. The not byte. Okay. Again, I don't know why you want that. Add the 2 input bytes. Each output byte of the input of the output should be a result of the addition of the corresponding bits from the inputs and potentially a carry. If the result does not fit in the 8 bits, turn the output carry. You can think of it as a 9th bit. Finally, there is an input carry as well. This is useful for chaining together byte adders to add larger numbers. You can think of this carry as adding either 0 or 1. You only need 8 full adders. What? Okay. Okay, there's a full adder. Adds 3 inputs and returns a sum and a carry. Is that not what we're doing here? So everything's on. Do I want it like that? Hang on, how the hell does the adder work? Adds 3 inputs and returns a sum and a carry. This one also useful as byte 1. Add the 2 input bytes. Each out. Okay, so I do need to do this. And I need to do 8 adders. 1, 2, 3, 4, 5, 6, 7, 8. And which pin is which? It doesn't seem to matter. Okay, well, input 1, input 2. We'll go ahead and do all these. This doesn't seem right. This doesn't make sense to me, but we'll see how this goes. Right, gray for ones, I guess. I don't know what I expected. Alright, 2s. Well, it seems to be working for the carry. Think of this carry as adding I see. Okay. So I think what I want is for this to be that, and then the rest of these carry like this. Shit. So now I'm doing white for 2. And then this final carry. Will be like that. So now I want 4s. I want 4s. 8. 16. And you're probably thinking this is some really peaceful music. This is not game music. This game doesn't seem to have any music. This is music from bardly.io. It's D&D music. Alright. 32. 64. And 128. Alright. It's doing what it's supposed to now. So having it carry like that is what you're supposed to do. Cool. Excellent. Unlock, add 2 bytes. Cool. Onwards. The SR latch contains 1 bit of information, but in a manner that is not very easy to load or save. Create a circuit that can save 1 bit of information. Oh, I'm sorry. The first input should determine if we load or save. Okay. Second input is the value to save, or this value should be ignored if we load. So wait, but where is it getting that value from then? Make sure you understand how the SR latch works. Think of what truth table for input to the SR latch should look like. Alright, well there's the SR latch. So for input, yeah, so we have that. I don't know why this might possibly work. Whoops. Items. SR latch. 1-bit memory. A and opposite of A. I'll put what A was last set to. Okay. So I know that this is just like 2 NOR gates. But okay. So save. Alright, so save will turn input 1 on. And what save does is it pushes this output through. Okay. Pretty sure we just want to use that? No. Okay, so when this is on, I want it to use that output. But when this is off, I want it to be the same output. Hang on, do we want an XOR in there? Probably not. But we'll see. So we've got that. Alright, so we've got that. Yes. And next, close but no cigar. So I think I just want it like that. No? Do I want it to be not? No, I do not. Hang on. Alright, so when we get this input, do we want an OR? I don't think we do. No, we don't. Because this has that residual save in there. So... Okay. So this seems to be directly linked to this. Hang on, okay. So we're saving 1 bit of memory, yeah? Yeah. There, we're saving. Got the memory in there. Yes. So it essentially functions as an XOR, as an XOR. No. Only one of these will be on. And it'll be opposite of this. So... I want a NOR? No. Why am I struggling with this so much? Okay, so if I've got that, okay. So when both are on, nothing happens. But I want a desired input, so I think I do need to invert this. So when both are on, we have this. Yes. Now when both are off, now it's off again. So maybe I want to invert that too? What if I have this inverted? Nope. I was close to that XOR, I think. Ah, shit. I had that inverted, didn't I? And so we've got no output there. But I think if I put an AND in there, like this, I'm kind of cheating now. So we've got that, but that's not working now. So if we have now let's do a NOR, see if that'll work. This is a mess. Okay, now that's working. Now that's a mess. 'Cause we've got now we've got weird shit happening. A and opposite of A. I feel like someone's screaming at me like, oh my god. It's so easy. I'm lost. Shit. I'm gonna look at the one before it real quick. So this is what we've got. Okay. So when input 1 is on, it goes to B. When neither are on, it stays latched. When input B is on, when input 2 is on, it goes to A, and it stays latched. But when both are on, nothing happens. Okay. Now we're here. So when both are on, nothing's gonna happen. So save. Okay. So when save is on, I want the value. So when action is on, I want value to go directly to output. Regardless of what it is. So... really, I kind of want it like that. But that doesn't work immediately because they're both on. So I'm thinking an AND gate should be fine for that. Yeah. But now they're both off. There's that, and now that latches. But now it's on. Because only that's on. Shit. I think what I want is an XNOR? XOR? So if one's on, it'll be on? No, that's definitely not what I want. We'll try it. Yeah, no, 'cause that's on. Maybe like that? So you've got that. Maybe something like that. Nope. That should be working. So that's still latched. Because that's just on. If you know the solution, please help me. Okay. So when this is off, it'll latch. It's a latch, so when it's off, it'll keep the position it had. So when it saves... Yes, when it saves, that's on. When both are on, nothing happens. So when both are on, it's kind of like a clear function. And I don't want that. So... I guess what I want is a NAND. So when both are on, nothing happens, basically. Okay, but we still fucked that up. It's because I just didn't... And this kind of just works as an OR gate, don't worry about it. So it turns off when save is off but load is on. And we don't want that. And then it's off when they're both off. No. Okay, so it's on when save is on, but load is off. Do I want it like that and that? That's not circular dependency. Fuck. Okay, so when both are on, I want the circuit to just be on. So we'll just do that. And then everything else should just be able to go through this? No. So we're still having that save is on but should be off problem. And again, that's not going to fix it. Alright. So we have that. Now when both are off, we want it to be on. No. Okay, we do need the latch. Okay, so basically, when save is on, I want the other value to go through to the output. So yeah, so that's even showing the problems I've been having. So when save is on, I want whatever the other output is to go to the end. And I don't care what it is. I just want it to trigger that. So shit. So we'll do this. So now that's off and it's still going. So when this is off, I want it to invert. Okay, but the problem here was they were both off, so it latched. Shit. Okay, so if both are off... So if both are off, I want that to do the same thing. No, I wanted it on. I see. Okay, so if both are off, I want it to go to output. No. I want it to be whatever it was last. So if both are off, I want it to take the latched output. Whatever it was. So if this is active, I want to turn that off. So I want to do... an XOR. Move that back. This looks so bad. Anyway. Fuck. Okay. So save is on. So it should be saving the null value. No, it wants it to turn off. Hang on, okay. Yeah. So... when save is on, I want it to override. Shit. I made this too complex, I think. Alright, so... and then I do still want the AND gate, so when they're both on, it'll just go. Okay. So I guess I think I just want to invert the save button. No. Because if we're loading, we're just taking the last value. Wait, so... okay, but that's... it's a problem because we're loading. So I wanted it to turn off. Hang on, hang on, hang on, hang on, hang on. Alright. So when this is on, so both are on, it's on. Both are off, it's on. No, we're just saving memory. Why can't I do this? Oh my god. No, okay. So we're doing that. And if both are on, yeah, I'll just go ahead and do the NAND gate, or the AND gate. So there's no reason not to. Yes. So the problem here is it's latched. But I want to force save. So I'm saving, but it wants it off. So what I may actually want is two outputs here. So we have one output that's just normal, and then one that gets inverted. And the saving determines which one you take. No. Yes, okay, so when it's on, I want it to turn off. No, we don't. When both are off, we want it to take the last value. Which is simply... Hang on. No. So, take the first one. Nothing's happening. But there's... So nothing's happening, so it should... Oh, it should have saved the on state. And it did? Why? Okay, so where it differs a lot So I'm wondering if actually the AND gate is what's messing it up. So yes, this first output sucks. So I think what I need to do is I need to invert it. But then the problem is now that that's off, this isn't doing anything. So really for the first two, it doesn't need this at all. But then for this one, there's nothing here. Which is when I want it to force its way through. To turn that off. I'm going about this wrong. This is taking me so long that I'm just gonna look it up. Because it's taking so long. I'm sorry, but I can't... Okay. What's this game called? Turing Complete. Turing Complete. And I believe this is SR latch. What was it called? Yeah, SR latch. Turing Complete. Game. SR latch. Please help. Please help me. Okay, well. So it's going to one output. So basically it kind of just flips, takes the other one. So I'm kind of converting two outputs into one, and that's a lot of what I'm struggling with. Please help. Half is 2-tick clock signal. Nope, that's not what I want. Help. Okay. Well, there's solutions, but that's not really what I want. And it doesn't even have all the solutions anyway. Again, I'm only looking this up because I'm struggling so badly. Do I have to look up how to actually do it in real life? Because it's not going to tell me here. I can't believe I'm doing homework for fun. Hold on, I think I might have found something. There we go. Yep, that was... Yeah, this is, what, saving gracefully? They don't have anything. Fuck! Please help me! I don't know what I'm doing! No, the problem is I understand how the SR latch works, but this is hard. Is there no hint? Game controls, bytes. Switch schematic. It is an early access game, so it is possible that they'll add something later. But still a struggle. Let's see if they've got anything to help me here. That's just a review of the game. That's just playing the game. That isn't even about the game. Fuck. Nope, I wanted images. Saving gracefully. Please. That's not what I want. You'd think I would know how to do this. But I guess not. Oh my god. Okay. In. Okay, so there's 4 that are wrong. And it's all places where... No, there's 3 that are wrong. And it's places where the desired output is on, but it should be off. So when both are off here, I want it to be saving the output. Okay. So that works just fine. So the problem here is I wanted it to latch. And so that's fine. But now I want it to unlatch. So that's fine. Hang on. So if I were to AND this for the input, maybe that would work. No. So I need that to push through. So maybe... maybe an XOR. Nope. That's one of the worst things I could have done. How about a NOR? Okay. Okay. That was worse than just having it normal. Okay, that was fine. Okay, so that's fine. And then it latches. So I think I want this to be like that. No, so... Okay. So what I've got right now, every single off input, yeah, it's just gonna stay latched. I want it to unlatch. I want it to switch to this when this is on and this is off. But not when they're both on. So I want the inverse of a NAND. I want a NOR. No. I want... So I've got an AND here. So when they're both on... Yes. I want it to... Shit. Okay, so here's the thing. It works. It works. It works. Because I forced it. But that's wrong. Because it's supposed to load. Okay, so to get a signal only when this thing is on, only when this is on. That's just that signal. Shit. I had a train of thought, and then I lost it. So I'm gonna see where all the other problems are. It's on when it should be off. So it turns back on when this turns off, because this is on. I think I need another one of these. So... Okay. So that's off. So for some reason that's on. Problem. All three are on, and it's off. Why? Because both are on. Shit. And now that's wrong. Because I'm fucking latched here. Okay, So the problem areas are here when they're both on, and here when they're both off. Because it should have held it. So it held the off position because this latched on, and I had no way of turning it off. That's the problem. I didn't turn it back off. So, yes. So I need to turn it back off. Hold on, so why did it work in the first place? So the first one, it was off in the first place. And then it was off, so nothing happened. But then it turned on. So it turned on, which turned that off. Because when this is hang on, when that's, what if I do this? Alright, so that never turned off, which is good. So it was always doing something. Yes, because it's either one or the other. But it's a shit show down here. Alright, so when it turns off, hold on, so that's, when it turns on, that's gonna latch. Yes. Yes, yes. And that turns on. I want it to be like that? No. Alright, the first problem's here. It's supposed to load. So it should be taking the last thing. So I want it on. So I guess when it's off, I want it like that. So they're all off. Why is that? Why are they all off? Because the AND should have triggered at some point at least. So they're both on. Oh shit, fuck, cock anus balls. Sorry. Okay, so that was right. Okay, so that triggered. But only because there was nothing going on here. Okay. Okay, so we've got this. Yeah? So when this is on, I want it to trigger that. I don't want it to stay triggered. When it's off, it's going to trigger this. Oops. Just to turn this off. But that's unnecessary. That's all unnecessary, because this is going to be... Because when it's on, that'll be on. But when it's off, it'll be off. So it makes no sense to have that. Because it'll just be on or off. What I need is something to force this to save or load. When it's on, I want it to force the bottom part through, regardless of what it is. So when it's on, this will be on. Hang on, so if I invert this, so that way, when this is on, okay. So when this is on, this will be off. When this is off, it'll be on. I think we've tried this already. Yeah, it doesn't work. Because when this is off, okay. I'm missing something. So when this is off, I want whatever the hell this was to just push through, no problem. So that would normally be done with an inverter. Yes. And then when it's on, yeah, but when it's off, I want it to... No, okay, so when it's on, I want to force this through. So for sure, make it off. Yes, so when it's... Yeah, when it's... Stop it. When it's on, it's on. I don't want this doing anything when it's on. I want this forcing this through when it's on. When it's off, I want this to be latched in whatever position it was. When this is on, I want it to be forcing this through. Let's do an and. And then a latch. So when both are on, it'll be on. Okay. So I want that like that. And then I want a latch here. So that'll be on. It'll stay on. But now this is wrong. So this is off, but this is still on because nothing happened to trigger this. So I get the feeling I need more than one of these. So I'm thinking, what if... So we've got this, and that's the output. And now this forces saves. This one level should not be taking so long. It shouldn't be this hard. There's gotta be something simple that I'm missing. And I feel like it has something to do with the fact that I'm not using other gates. Or I'm trying to, but... I feel like this is gonna control this somehow. So that goes through. I guess I kind of need a latch save. Do I? We do that? No. Already, it's a fucking mess. Yeah, because that does exactly the same thing that... I need something to trigger this, to turn this off. What's wrong? Maybe the output doesn't go through the SR. The output... Well, no, the output latches in the on or off position. So maybe it has something to do with having a NOR as part of this one. I could just do that. So if I have that, so then that'll be on. So now it's just gonna be... Now it's just gonna match the output, which is not what I want. I think the output latch should be way over here. I think there's something that happens after the output. So then we'll invert the input. Just like that. So we've got that. Obviously we want it hooked up like that. But now that they're both off, we wanted that to stay latched. So when this is off, I want it to do nothing. So I think I want that latched. Yeah, so when it's on, yeah. So now that'll be latched. Hang on, yeah, so there it's on, and then off. I think that is going to benefit me, actually. I think I got rid of that idea too soon. So we want that. And so when that's on, I don't want this doing anything. When it's off, no, I think I want this inverted again. I want it like that. Nope. Shit. When this is off, I don't want it doing anything to this. I want this to stay latched when it's off. Shit. So I only want this to change phase when this turns on. So when this turns on, this'll glow. And I want whatever this is to be going through. stay that way. But once it turns on, I want this state to be carried through. So I guess when this turns on, I want this to become a knot through here. So I need another one of these. So when this turns on, okay, so this is gonna get moved up here like this. So when this is on, this is gonna make sure this triggers. And this is gonna be a knot. Through here. And then that's gonna come down and trigger that. Nope. So what happened there? Should be loading. Should have saved the last state. Why is this on? It's on because I set it to be on. Why is this off? It's off because this is set to be an and. So should it be like that? No, why is this on? Because this is on. So this is on, so it's so when this triggers, and when this is a knot, then this triggers. So, okay, so why is this on? It's on because this is off. Is that right? No. Now that's the problem. Does this need to be a knot? Shit, I missed. No, that's worse. Alright, so this is what I had. And that worked fine there. It's off and it's working. But now it turns on. Forcing this off. So because this is on, I'm getting closer. Okay, so essentially, this is right. However, I want this to trigger. I want this to turn off when both this, when the top one is on and this one is off. So I guess I just want a simple AND gate. So the problem here is it turned back on. So I need this to latch too. Okay. So I'm going to move this back. So that worked as intended for turning this off. So it turns off in a lot of places where it's supposed to. It turns off, so it does change phase every time there's a new save. The problem is, once this loads back in, so I need it to keep phase until this turns back on. Yeah. So if this is on, that'll turn that on. And if it's off, nope, same problem. But now that that's latched, they're all going to be off. I need something to turn this, to change this. Because just like this, it'll turn back on as soon as one of those latches. So to even turn this on in the first place, I need an AND gate that is both input and that. I did it! I did it! Ah! Finally. And that unlocks 1-bit memory. Oh, thank God, I never have to make that again. Good. Onwards. That was for sure the worst one. Alright. Negative numbers. To know the difference between things, you need subtraction. To get subtraction, you first need negative numbers. We need a way to have negative values in bytes. The scheme we have been using so far can represent all numbers from 0 to 255 using a byte. The scheme is called unsigned, since it only deals with positive numbers. We need a scheme that allows negative numbers, normally referred to as signed representation. Additionally, it would greatly simplify future circuits if the representation works with the adder you already made. Change what each bit means by changing the numbers. Toggle the bits to see the result. Okay. So I need -127 to 127 representable. -1 not representable. 0 to 127 works the same as... 0 to 127 the same as before. Works with adder. So I don't have anything over here. So... am I just doing that? Should be 64. Yeah, but that's now -64 is the problem. I think this can just be changed to an entire negative number. So if I have -1, no? I don't have an adder. Level log. Scheme is called unsigned. Yes. Toggle the bits. Yes, I've got that. How about this? That should be 1. Yeah, but it's -1. I genuinely have no idea what to do here. Profile. Play. Manual. Truth tables. Alright, this has to stay 1, I guess. Okay. Okay, so... I see. Onwards, I guess. So much more. My main worry is I'm gonna forget everything by the time I play this again. Alright, next one. Create a component that switches an input byte on or off. What would this look like if you were only switching 1 bit? What would the truth table for such a component look like? Okay. So it switches a specific input byte on or off. A whole byte. Okay. Output if the byte switch is on. Okay. Yeah. But now this should be off. So what I want is, okay, so if this is on, stop it. I'm doing this really weird, but basically, so if that's on, it'll be on. No, that's just always gonna be on. Fuck. Full adder adds 3 inputs and returns a sum to carry. I think that's just a full adder then. No? Okay, so the full adder just turns it into ones and zeros. Could it possibly just be an AND? Nope. So I think I do have to convert it into this and this. So I'll connect those. So now I'm just gonna do 8 ands. 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And each of those are gonna connect like so. I don't like the way that it connects. Looks stupid, but whatever. Right. And now the in is gonna go to all of these. And I'm gonna do teal for the rest of these. I was looking for a simpler component, but I'm wondering if there just isn't one. Yeah, that looks right. Yep. Switches by on or off. Yep, that sounds right. Okay, we are experimenting with how backgrounds influence cognitive functions in Earthlings. Great. When invert is on, output the opposite value, otherwise just output value as is. What? So it's an XOR. Despite the funny background, you figured out that this was the XOR gate in disguise. Well done. Okay. Unlocks. Game unlocks are not real rewards, knowledge is. Oh, okay. Even though he did not pass our test, we decided to keep the dog. Well, good. Unlike most Earthlings, he is fluffy and follows simple instructions well. I like dogs. We might want to team you two up since you complement each other's shortcomings well. When the bit selector input is off, output byte A, otherwise output byte B. Okay, so when it's on, B, when it's off, A. Do I have the bit select? Do I have the... Yes, I do. So it was... Okay, when it's off, it's A. So... when it's on, I want B. And when it's off... Stop it... There we go. I want this. Cool, so that worked. Unlocks MUX toggles between 2-byte inputs. Cool. Taking the input as signed, where the 8th bit is -128, make a component that takes a number and negates it. For example, a 4 negated would become -4. A -9 negated would become 9. Okay. So... okay, good. So I've got that. I want this. Oh, I thought that was negative 128. Okay. There we go. Invert the sign of the number. Yes. So if I have 1... hold on. So if I have 1... and I want negative 1... I'm going to want to connect all of these. Now if I have 2... really? You're not going to let me change the color? Fine. Yeah, that'll be a problem, because I won't have just one. I'll have other ones. Fuck. Fucking hell. Shit. Let's do white. Hopefully I won't have negative 128. Actually, maybe I was on the right track. One will look like that. Whoops. Do I need 8 of these? I hope not. 2. Will be everything but 1. Yeah, so it's just gonna come across like that. Nope. I want colored line, please. Fine, be that way. Nope, I think I do need 8 of these. do gray. And then we'll do 8 receivers. Actually, I think I need 9 receivers. I am curious though, if I just hook up like a 1 and a 64. 1. And 64. Yeah. Okay, so that's why I'm thinking this. So if I've got... Stop it! I know! Shut up! Now I can do this. Alright. 1. We'll be going to all of these. So now if I have 1, -1, I mean. Okay, so that's a problem. So it looks like I do have to do all of these in the same one. But that's doable. I just don't want to. And I am concerned that this isn't going to work. Yeah, why did you change color like that? I'm having a hard time seeing where I've already placed something. There we go. Pink. Oh my god. Well, let's try it. -1? Why? Is it because all those are headed back now? Am I just... connecting across? Like, I think I am just connecting across like before. No? So... the problem I'm having is... okay, that's 2 bytes. It's not really what I want. So I want... alright, hold on. So if I've got 33, and I'm negating it, so I have 32 and so I have 32 and 1 from here. And I'm connecting that to 128. So I'm gonna do that real quick. So there's 33. So I've got 33. So I have 33 there. It's negative 64. Oh. Wait, no. And then also to that. So it's negative 32. So I actually want that. Negative 65. So no. Is this what I want? Negative 95. So no. Oh, I think... Do I want everything connected except that number? Negative 34. But now it's at negative 33. But... So if I have it like this... Yeah, that's 33. But if I have it like that, it's still 33. So... invert the sign of a number. Okay, so for 1, I want everything except for 1, I think. Nope, I want them all. Which is good, this is what I want. For that, in particular. But now, if I've got 2, I want... Oh no, I can't fucking read that. Eight, 16, 32, 64, 128. So now if I press 2, I still get negative 1. Why is that? I wonder if what I need is this instead. Just quickly make sure it's connected to 4. Oh, I deleted all of those. Oopsie. Yeah, that shouldn't be giving off any signal, so what the hell was going on there? Okay, hold on. So if I do a knot, what do I get? I've got a 32 there. Oh. So I've got 32, and now it's negative 33. So I need to add 1 to that. Now if I've got 36, yeah, I just need to add 1 to it. So I'll do that. Full adder. Nope, not quite what I want. I want an add right here. So I want that. And I want that. So if I have 30. So I've got... There we go. Excellent. Cool. I unlocked the negator. The negator. Alright. Next up. Is this the computer that I'm building? This whole thing? Or am I gonna build an entire freaking computer later? Create a circuit that can save or load a byte. No! When the first input is on, load the memory and send it to output. When the second input is on, save the input byte. No! I don't wanna. Alrighty. I guess. But I have the 1-bit memory. So how does that work? What are we looking at here? Save enable, save value. So if I've got that, and the value is like 4. It should be saving the value, but it's not. Why? Why is it not loading the value? Fork. Alright, we've got 36. I don't think I have a bit saver. Oh, that's... Oh, I see. Yeah, okay. Okay. So, I need to do this. I need to do a byte splitter. And then I need to do a byte maker. Okay, and then I'll just connect those real quick. And so for each of these, I need the 1-bit memory. 2, 3, 5. No, I want that. 4, 5, 6, 7, 8. And now it's going to remember all of these values. I'm going to change to green. I prefer green. There we go. So now saving should just work like this. Save, yeah. Do nothing. So we're only looking at save right now. Saving, doing nothing. Save. -38, so it should be saving. And it is. The desired output is 0. What's the problem? When the first input bit is on, load the memory and send it to output. But desired output, okay. So I don't see what the problem is. Desired output. All of the desired states are 218. But for some reason, they always want the desired output to be 0. But that doesn't make any sense. Here, your desired output is 0. How about now? Save. Okay, but the problem is when I need to load. What's this? So I'm getting nothing. So I think what I need to be doing is I do need to be saving all of these bits. Whoops. But there's 0 until I want to load. 2, 3, 4, 5, 6, 7, 8. So... So we've got that. And then I want a NOR gate so that it only loads when this is off. Let's try it. There we go. Load. $217 saved. 46 saved. 108. Load 108. That worked. Load 108. Again, that worked. Because we're... Wait, but... Oh yeah, because we're not saving. Save 92. Save 176. But that says -80. Do I just need to disconnect that? There, that should do it. Yeah. No. Why is this a problem? Save 92. Save 176. It should have done that. I must have one double connected here or something. It's one. Nope, it's this one. 2, 3, 4, 5, 6, 7, 8. I may have also had the wrong side connected. Still a problem with 176. Save 176. Yes. I've got it. So 16, 32, and 128 should all be on. They are. Why are these doing that? Oh. running into that problem there with these fucking things. Yep. That's the problem, alright. Alright. So what I need to do is get a bunch of AND gates in here so that it'll force its way, regardless of what these things say. No, so... Okay. So if this is on... So basically I want it so that if this is running, none of these are able to do anything. So I'm gonna do a bunch of AND gates. 1, 2, 3, 4, 6, 7, 8. And so, connect. I'm gonna do a different color so that I can tell it apart a little better. I'm gonna connect all of these. Yeah, okay. So if this is on, this is gonna be off. So essentially what I'm doing here is making it so that these can only turn on when this isn't working. So let's try it now. Perfect. Now I've got a register for 1 byte memory. Excellent. And we'll be finishing up pretty soon. Onwards! So we'll do this one. Create a component that can switch a signal between 2 pins. Okay. Yeah, so that's pretty easy. So if input's off, output 1 is on. So we'll do it like that. Just like that. Yep, and now we've got a demux. Toggles between 2 outputs. Onwards. Yeah, some of this is really easy, and then some of it's just so freakishly difficult. We want a thing just like the other thing, but a bit bigger. Okay. Oh, geez. With 3 bits of input, there are 8 combinations. Make a circuit that selects 1 output for each of the 8 combinations. No more or less than 1 bit should be on at a time. Okay. Okay. Okay, so when none of these are on, So I want an AND gate. Nope, I'm gonna do a different color for each of these. So I've got an AND gate. But I only want it to work. No, actually. So the AND gate will take you to bit 8. But if it's not on, I want it to go to bit 1. 1, 2, 3, 4, 5, 6, 7, 8. Yep, okay. Yes. And I'm gonna actually do that. So now, if only 1 is on, okay, so I want 1, but not 2 or 3. And that'll turn on 2. Similar thing here. I want not 1 and not 3, but I want 2. And that'll be for 3. Now I want 1 and 2, but not 3. And there's probably a much simpler way I could be doing this, but I'm not. Oh, you know what? Okay, so for the one for 2, this one that goes to 2, so this one, what I can do, so if I do not that, if it doesn't meet those requirements, then it's 7, and that is true. So we have 7 there. And so for 3, this one, not that, is 6. So now this one, for 4, requires both 1 and 2, and not 3. And that's 4. But the not version of that is 5. And that should work. Nope. Shit. Oh shit. Yep. Wait. Yeah. Yeah, I can't just have the knots in there like that, can I? No, I cannot. Yeah. Alright. So I need the AND. I need the NAND. No, I need... the NOR. But I want 3 input, so I'm just gonna do a NOT version of that. Shit. We'll do that. We'll do 1, 2, 3. We'll do that. So now if none of these are on, then we have 1. Yeah. And now for 1, 2, 3, 4, 5. Now for 5, we do want not this. But the problem is, if I just put not this, it's always going to be on whenever it's not a 4. So I do need it to be... Oh, no. I can put it kind of like that. And do... like that. And then just have 2 NAND gates. Like so. And do that for 5. Yep, but 6 doesn't work yet. So for 6, that is this one, but not quite that. So we're gonna do this. We're gonna do the same thing. Nope. I don't want that there. I'll put it like that. And just bring it directly down to 6. But, like that. And then like that. And then I'll put a NAND gate in. Put it in. Like that. So that should work for 6. And then for 7... no, the same thing that we did for 2. Right here. I'll just do another one down here. Easy peasy anyway. So for 7 we want 2 and 3 on. But not 1. And yeah, it's all fucky, but shh, it's fine. Yeah, there we go. We had our intern add a disable bit to this component. We were tired of looking at him running in circles, and were looking for other pointless and tedious tasks to give him. Cool. Unlocks bigger demux. Using the unique combinations of 3 inputs, toggles 1 of 8 outputs. Onwards. So that's actually going to be it for tonight. I need to make dinner and eat. So thanks for watching. This has been Turing Complete, and I will be back with this game because I love this game. It's fun. Yep. Have a good night. I'll see you tomorrow with some Minecraft. Bye-bye.